In this video, we will review some vector basics. Now, vector v has an initial point at -2, 3. So -2, 3 is the initial point, and it has a terminal point at 1, 2. So that's 1, 2 would be right here. So a vector goes from the initial point to the terminal point. So the vector would look like this. All right, so that would be a sketch of that vector v. Similarly, vector u has an initial point at 0, 0, and a terminal point at -4, -5. So that means that this vector begins here and ends here. So this would be a sketch of vector u. Okay, what is the component form of vector v? Well, the component form is the horizontal change, comma, the vertical change. So looking at the drawing, we can see that the vector goes to the right 3 and down 1. So that's going to be 3, -1. What's the component form of vector u? We can see that it goes left 4 and down 5. So the component form would be -4, -5. All right, what is the magnitude of vector v? Well, we can use the magnitude formula where we take the square root of 3 squared plus -1 squared. This is how you get the magnitude from the component form. So this would be the square root of 9 plus 1, which is the square root of 10. And what is the magnitude of vector u? Same thing. -4 squared plus -5 squared. That's the square root of 16 plus 25. So that's going to be the square root of 41. Number 23, what is the direction of vector v? Well, for the direction of vector v, let's do a little sketch here. Vector v goes right 3 and down 1. So if I place it at the origin, that's definitely going to be in the 4th quadrant, like this. Let's make a little triangle out of it. So it is right 3 and down 1. We should be able to easily find the reference angle r by doing the tangent of r, which should be -1 over 3, opposite over adjacent. And then we can find the reference angle by doing the inverse tangent. Now I'm going to ignore the negative sign and just do 1/3 because I just want the positive value of r, and put this in your calculator. So that's 18.43 degrees. So the direction of this vector is the angle as measured from the positive x-axis counterclockwise. We call that theta. So theta was on its way to 360 degrees, but it stopped short by this reference angle. It stopped short by r. So theta, the direction, should equal 360 minus r. So 360 minus 18.43. So the direction of v is 341.57 degrees. All right, what is the direction of u? So vector u is already sketched at the origin, so I can just use that picture. So again, the reference angle is right here. Let me draw a little sketch. So I should be able to find the value of the reference angle by doing the tangent of the reference angle. This is left 4 and down 5. So the tangent of this reference angle is going to be opposite over adjacent. So I'm going to put 5 over 4. I'm going to ignore the negative signs because I just want the positive value of this reference angle. So r should equal the inverse tangent of 5 over 4. Put that in your calculator. So the reference angle is 51.34 degrees. Now the direction is the angle to the vector measured from the positive x-axis. So this angle theta is the direction. So how big is that angle? Well, it's 180 degrees and then r more than that. So theta is going to equal 180 degrees plus r plus 51.34. And that's going to give us the direction. So that's why the direction is 231.34 degrees. All right, number 25, write vector v as the sum of unit vectors. Well, look at the component form, 3, negative 1. We're just going to rewrite this. Instead of writing sort of an ordered pair for the vector, the horizontal component can be written as 3 times the unit vector I, which is the vector I is a horizontal vector that has a length of 1. So 3 of those would be the horizontal component of vector v. And then we will do the vertical component using the unit vector j. So I will say minus j. Notice how I put a little hat on the top of this to show that it's a unit vector. Okay? Unit vector j is a vertical vector of length 1. Okay, so 3i minus j, that's the sum of unit vectors. That would be the same as vector v. Similarly, looking at the component form for vector u, we could simply write negative 4i with a little hat, and then minus 5j with a little hat. Notice there's no comma and there are no brackets. It's just a sum of vectors. Number 27, find the component form and sketch 3v. All right, well 3v is going to be 3 times 3, negative 1. So that would be 9, negative 3. So now we have to sketch it. It really doesn't matter where you start a vector. So I'm just going to start this one at the origin, but you can move a vector anywhere as long as it has the correct horizontal and vertical component. So this would be right 9 and down 3. All right, so right 9 and down 3. So this would be a sketch. Okay, now let's do the component form and sketch for negative 2u. So negative 2 times vector u, which remember is simply negative 4, negative 5. So that's going to give us positive 8, positive 10. Okay, so again, I'll just start this from the origin, and I will go right 8 and up 10. So right 8 and up 10 would be right here. All right, so there's a sketch for us. Let's look back at the two sketches we just did. I think we're supposed to illustrate in the sketch the nature of 3v, meaning it's 3 times vector v. So we should be able to picture this as if you think about vector v and how it was over 3 and down 1. So vector v is like right here. So 3 times vector v should be 3 of those, like this. Okay, so now we've illustrated 3 times vector v. And similarly, think about how vector u is -4, -5. So that would be -4, -5. Okay, so this would be a single vector u. And then -4, -5 again would be like this, -4 and then -5. So this would be 2u. So of course, -2u would be the same thing, but in the opposite direction. Okay, so now we've illustrated what really is happening. Okay, and that's going to be even more important when we do number 29, because we are really supposed to show 2v plus u. We're not just supposed to do the algebra and then draw the result. So again, vector v is vector v is 3, -1. So a single one of those would be like this. Okay, 3, -1. Right, so here is a vector v. Okay, so 2 of them would look like this. Uh-oh. Okay, so here is 2 vector v's. Okay, and so now we need to add a vector u. So let me switch colors. Vector u is left 4 and down 5. So when you're adding vectors, you put them end to end. So I'm going to start vector u that I'm adding at the end of vector 2v. So I'm going to start here, and I will go -4, -5. Okay, so this is vector u, and this was vector 2v. Now the resultant vector, 2v plus u, will go from the beginning of the first vector to the end of the second vector. So the resultant vector should look like this. And so this is the vector 2v plus u. All right, now let's do it algebraically. If I do 2 times vector v, that should be 6 comma negative 2, and then plus negative 4 comma negative 5, and then adding the corresponding components, I'm going to get positive 2 comma negative 7. Okay, so this should be the component form of 2v plus u. Let's see how that matches up with what we got graphically. This says right 2 and down 7, and sure enough, our resultant vector goes right 2 and down 7. For number 30, we need to sketch u minus v. So here's vector u and here's vector v. When you're subtracting, the easiest thing to do is to put them tail to tail. Then the resultant vector of u minus v will be across the ends from end to end of the vectors. It's just a matter of which direction to draw the vector. And it's simply the opposite direction from the way it's written. When you write u minus v, the resultant vector actually goes from v to u. All right, so I'm just going to go from the end of v to the end of vector u, terminal point to terminal point. So this is my resultant vector. U minus v. So now let's take a look at the algebraic method, where we will simply do negative 4 minus 3, which is negative 7. Negative 5 minus negative 1 is really negative 5 plus 1, so that should be negative 4. Okay, so algebraically, we get the component form of u minus v. And now let's see how it matches what we got graphically. It should be left 7 and down 4. And you can see that vector u minus v does go left 7 and down 4. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.